This is module CM3292, and this is the gas chromatography mass spectrometry experiment, experiment number 3B. As usual with these videos, this is about the operational use of the equipment. I'm not really going to talk very much about the practical, just highlight the techniques you'll be using. Okay, so if we come this way, when you get in the lab, you'll find that the computer system will be on, and the screen will look like this. The GCMS spec, which is here, will be on. You'll have power lights on there. Your pumps underneath and to the side will be running. And over here, this is the helium gas supply for the GCMS. That will be turned on. Okay. Over here. So, in this practical, we are going to do headspace sampling, and I'm going to demonstrate that for you first before we just walk through the operation of the GCMS. So, the sampling setup is on the other side of the bench from the GCMS, and we'll walk around there now. You'll be provided with a sample. This isn't one of the samples you'll be using, it's just for the demonstration purposes today. And the sample is actually in a vial with an injectable septum in the top. You'll be sampling the headspace of that sample, that's not the liquid, above the liquid, with one of these, which is a fibre sampler. If you look at this device carefully, you'll see that there is a needle and a sort of plunger with a little stop setting. As I carefully push the plunger out, I want you to watch the end of the needle. And I twist it to lock it in place. Now, I hope you can see that something came out of the needle. I'm going to retract it now. That something is the fibre, and the headspace gases from here will absorb on that fibre, and that will comprise our sample, the thing we're going to inject into the GCMS. This requires care. The fibre is very fragile and incidentally quite valuable, so please be very careful. The first stage, with the fibre withdrawn inside the needle, safe and protected, we're going to simply place and just maybe a few millimeters insert the needle through the septum. The needle should get nowhere near, I'll turn that round, should get nowhere near the top of the liquid. I'm then going to tighten the clamp so that I don't have to hold it. Now we're going to have a look. The clamp is very slightly loose, so I can move this up and down. As I move this down, you should, within the sample vial, see the needle. So I'm going to withdraw it so it's about level with the metal cap, and then I'm going to clamp that in place. And if we look underneath, all I can see, you may not be able to see, you can just see the tip of the needle out the bottom of the cap. Now, we need to sample for a set period of time, and your script tells you about that. To do the sample, very, very carefully hold the body and watch where the fibre goes. It must not go into the surface of the liquid. So I'm gently pushing that down, so I should be releasing the fibre. I can see the fibre, and I've twisted it to lock it. So the fibre, that is now sampling, and we have clocks which are set, so we're just going to start You need to sample for whatever time it says in the script, and whilst that's sampling, we're going to go away and do something else. So that's sampling. We're going to go around now and look at the operation of the GCMS. Incidentally, the clocks are alarmed, and so they will bleep after the 10 minutes is up. Now, in addition to the practical script, also you will find, this is it, you'll find a operation procedure here, which is on the bench. And again, you'll need to look at that and hopefully relate that to some of the things that we are doing here. Okay. So the system is running. We need first of all to click. Okay, so we're at the GC screen, and the first stage, according to our instructions, is to click the data acquisition icon, which is this one. I'll move the mouse there again, that one, as here. We now need to click the sample login, and here we can put in our own sample name. I'll leave this one in here at the moment, which says SDME1JW, but you would maybe put your own name in there or something that you will recognize. We then click OK. Right. So you've keyed in your sample name and you've clicked OK. Then you need to move to the download icon, which is there, and click it. Now, this data file already exists, so I'm simply going to press increment, which means the data will be saved in this file name, but it will add a number afterwards. If you've got a particularly individual name, then it won't already exist, but you may well still be asked whether you want to increment. At this stage, we're ready to do the injection. Now, in your practical, there's a specific amount of time you're going to wait. This is a bit more like a Blue Peter show. Here's one we did earlier. I'm just going to take that sample as if it's been there for the right period of time. So, okay, in your imagination, the alarm has gone off and we're sampling. So the first thing is to hold the body carefully and very carefully twist and release, so the fibre has now been taken up inside the needle. Okay, holding the sampler carefully, hold the sample and out. So this now contains your sample, the fibre is loaded. Okay, so this is your sample. The GCMS is ready to run. The next stage is the sample that you have absorbed on your fibre has to be introduced into the GC. Now, as you know from your Year 2 studies, the injection port is heated, so we're going to use this needle to insert the needle into this injection port, and then when it's in there, very gently release the fibre. So I'll do that now. So we're going to introduce the needle, the fibre's protected inside the needle into the heated injector. So as in Year 2, hold the bottom of the needle so it doesn't get stressed. Remember the injector's hot, and gently insert the needle into the injector. Then you need to very gently extend the fibre and lock it in place and press start. Now, thank you. This needle needs to be in there for 2 minutes. That's how long it takes to degas your sample from the fibre onto the GC column. Okay, so the SPME fibre sampler is still in the injection port, degassing, and looking at the clock, we have a few seconds to go. I'll wait till the alarm goes off and then withdraw the sampler. So, okay, the alarm has gone off, I'll stop it. Now, this is important. When you remove the sampler, the first thing you do is very, very gently to get the fibre back inside the needle so it's hidden. Once it's in the needle, it's safe, and you can simply remove the sampler, and that then is the end of that process. Now, this is an automated system, so in fact, what is happening now is the chromatographic system has kicked in, and very soon you will see, it's not quite there yet, it takes a few moments. In a moment you will see the trace begin to appear here. Okay, now if we look at the screen again, you'll see two things have happened. It takes maybe 30 seconds or a minute. You can see first of all here that you get the GC trace as you normally would. But this window underneath is giving you the mass spectrum of what is coming into the mass spec at any particular time. We will let this run. You can watch it if you like. There's no harm, but you're not going to be able to change it. What you will see, as with any other GC trace, is peaks at various points along this trace. So we'll wait for a moment until the trace is finished. Right, okay. Now, in this particular example, you can see we only have a very, very tiny single peak there. You will have larger peaks, but what we'll do is demonstrate for you how you then get your data out of here. Okay, the first thing we do is, so it doesn't look like we've got very many peaks on here, but that doesn't matter because we're just demonstrating the equipment to you, although as I speak we do have at least one peak, which is comforting. The system is automatic and it will turn itself, the run will end in a few minutes time, and at that point I'll just use that one peak and show you how to get your data off of this equipment. Okay, we are waiting for the automatic program to end, and it should end at 20 minutes. So when it gets to 19 or 20 minutes, we'll resume. Okay, so this run will end automatically after 20 minutes, and you have to wait that long. You have to wait for the automatic run to end. And if we look carefully, you can see we have a peak there. We have another small peak there, and we have some general stuff on the baseline. So we're nearly finished. Now you will have larger peaks, and a number of them when you do this practical. But what I want to think about for a moment is this mass spectrum, which is changing all the time as the run progresses. what you are seeing is instantaneous mass distributions or mass spectra for the effluent which is coming out at the end of the GC column there now. So at the moment we are at, I don't know, just under 19 minutes, and so this spectrum is showing you exactly what the mass spectrum of that effluent is at 19 minutes. Okay, we need to be patient. We have another minute or so, at which point the run will actually end. So, like us, you have to wait till the end of the run at 20 minutes. Okay, so we can see that we've only got a few seconds of this run left, and what we should see in about another 10 seconds or so is what the screen looks like when the run ends. We've got to 20, and okay, turns out it's slightly more than 20 minutes, but you can just see what's happened. Down here your buttons have changed and the run has actually ended. You can hear, actually, although you can't see anything, you can hear the fans running in the oven as they open some of the oven flaps to cool the oven slightly. Okay, so what we will do now, and again I'm looking at the instructions on here, is we will run open post run, which is part of this program, to actually be able to analyze our sample. Okay, so this is the previous screen that we've been using the whole while, was actually the console. You were seeing real time what was happening. This is a post-run analysis screen, so we're going to load the file that we've just recorded and then analyze it. This screen tells you nothing about what the GCMS is actually doing. Okay, so using the description here to make sure you're okay, in post-run we need to be in qualitative, and you can see that the system is already in qualitative, so that's good. We now need to go to File, Open Data File, and you see CM3292 and Student Data. Double click Student Data, and this is the name of our file name that we're using, so we click that and open. So let's just see what we have. What we have here is our chromatogram in the same way as you've seen with in the second year with GCMS, and we have a couple of peaks. Now we're going to zoom in on the largest peak, as you will for your work. And so what we will do, okay, so we will click the register target spectrum icon, and then we can close the window, which we've done. Okay, we can now double click the report in the assistant bar, which is there, and this will generate for us that report, which tells you, gives you the mass spectrum and tells you what it thinks the identification is. At which point you have done what you need to do. You can click preview and print, and then effectively you've finished. The analysis stage on here of establishing which components for your practical, there'll be more than one, is actually present, will take longer than this little demonstration. Okay, I know with the GCs you often turn them off. This one you should not turn off. I think you can close these windows. Okay, So what we'll ask you to do is leave this as is, and then we'll sort it out after you've left. When you're doing this practical, if you could report to the technical or academic staff when you've finished, then we know when we can come and deal with the machine. Okay, thank you for watching. Goodbye.